All the other ones. Decimal was like 2 years ago.
Okay. All right, guys, let's take a look here. All right. So if you had a lot of trouble with this, you might want to come see me or somebody. It shouldn't be overly difficult. It might be a long time since you took your last math course. I don't know. But these should be pretty straightforward. This first fraction should be really easy to convert to decimal. What do you do? What's the easy way to make this a decimal? Not divide 3 by 5. That's one way to do it. What's the quicker way? Multiply by 20 or just 2, either one. Because what are decimals? Decimals are fractions that happen to fit into our base 10 number system. We have a base 10 number system. I don't know why. So if I make 3/5, I could either make it multiply by 2 and make it 6/10. Because that is a decimal now. That is a fraction that I can write as a decimal. If I multiply by 20, I get 60 over 100. Same idea. 6/10, how do you write that as a decimal? 0.6, I love it. And of course, math wouldn't give a shit if you put another 0 there, right? Math is like, all right. Science interprets that differently. Yeah, it's sig figs in science. So percent, how do you make that into a percent? Yeah, move the decimal which way? 1, 2. So notice that the percent number is always bigger than the decimal number because the percent symbol means what? Out of 100. So it's the percent number, it hasn't been divided by 100 yet. Another little thing you can do is you can write the letters D and P in alphabetical order. Decimal to percent, you go that way. Percent to decimal, you go that way. It's amazing. I like it. Bless you. So what about this one? How do you make that into a decimal? 1, 2. That's right. Go on. And then what's 0.427 as a fraction? Yeah, tenths, hundredths, thousandths. 427 over 1,000. Lock it. And then 0.064, how do you make it into a percent? Bam, bam. 6.4%. And then to make it into a fraction, it's the same thing as the last two. Tenths, hundredths, thousandths. 64 over 1,000. But this kind of problem, I actually don't even want to see it reduced. Because normally people use the calculator and they can reduce it for you. That's crap. Now this is a good example of us being the humans. We made math. Math doesn't tell us what to do. We tell math what to do. People look at that and say, it's already so small, it's got to be 3 here, but which way do you move the decimal? Bam, bam. 0, 0. Holy shit. Bam, bam. 0, 0, 0, 3. So put 2 more zeros in front. Everybody with me? And then what's that? 3 out of tenths, hundredths, thousandths, 10,000. Okay. All right. Everybody doing all right? You guys all right? Mm-hmm. Yeah? Okay. What about this guy? Let's go fraction first. You have a couple different options for fraction for this guy. Notice how it's a mixed number. Just got a whole number in a decimal piece. So you could write it as 1 and 12 over 100. Like, just humor me and just tell me. Some of you guys are like, it's too easy. I don't want to answer that one. I'm saving myself for a harder question. How do I make this into a percent? Move it over twice, right? So it'll be 112%. And 112% is 112 over 100. So both of these are right for the fractional piece. Because how do I change that into a mixed number? 100 times 1 plus 12 is 112. They're both the same number. All right, cool. I like it. What about this guy? How do you do this guy? Yeah, not easy to do, is it? 16 times what is 100?
6.25.
Shit, and you did all that by hand, which is not impossible, but it's like, good lord. No, that's possible. Yeah, you can do that. Or what's another way to do this? Divide it, because that's what a fraction is. It's division. So you can divide 16 into 3. Kind of cut out a step there, but that way works beautifully too. I like it. Even some of you guys, let me see if some of you guys get this. What's 3/4 as a decimal? 3/4. 0.75, right? We all know 0.75. 3/16 is 1/4 of that. Anybody see that? What's 1/4 of 3/4? 3/16, right? So if you take 75% and cut it in half twice, you got the answer. Do you guys see that? All right, some of you guys are like, I don't give a shit, man. I got this little thing I bought. It does all this for me. But part of you should be upset if you don't quite get what I say, because we made numbers. We should be able to work with them totally ourselves as humans, because we made them, right? Anyway, so if I do all this business, what do I get? 116, 140. What do you get? 1, 8, 9. What's that?
1875.
All right, good. I'm just bored. 1875, and then you have to move it over 18.75%. If you took 75%, cut it in half, you get 37.5. You cut that in half again, you get 18.75. All right, what about this guy? This is the one that really upsets me, that people, less and less people really know how to do this, but it's class of 20 people with 3 left-handed people. So what percentage are left-handed? How do you set that up? 3 out of 20, 11. What does this mean? This really drives me insane that so many people think that means divide 20 by 3. I have no idea what the shit that's about. This is 3 divided by 20. I know your brain goes, you can't fit 20 into 3. But then we go, all right, wait a minute, I'm human. I know this is just going to be a number less than 1. No big deal, right? Don't just say, yeah, brain, you're right. No. The easy way to do this, of course, is to multiply by 5 to make the bottom 100. So this is 15%. Sweet. I like it. Now, real quick, a lot of you guys are like, probably, hopefully, a lot of you guys are, this is really easy. I just need to make sure everybody's on the same page and understands the things that they have to be able to do quickly in some of these problems. You don't want these things to be what's slowing you down. Now here we got something that might have been more challenging, possibly. How do I solve this for x? What's the suckiest thing about this?
X is on the top.
There's a top, so, which means there's something on the bottom. There's a fraction, but what's beautiful about equations is there's a lot of things I can get rid of that I don't like. If I see fractions in an equation, I don't like them, I can get rid of them. I can kill them. How do I kill this? So let's see, multiply by s. Now, what happens to the s? It dies. How in the hell is there anything left to distribute? So I always see that. Somebody has an s left alive, a little zombie s. And here I get sz equals x minus m, and of course there's one more step for x. What? Add m. What's happening to x? Taking m away. So I better add m on top, so I just have x by itself. So sc plus m equals x. This is an equation we're going to use in this class. The one thing I didn't put here, that I didn't want to get in the way right now, is I would have put the symbol mu there instead, but doesn't that look a little bit like an m? People normally make it an m, and I try to tell you it's not an m. It's a u with an extra leg. And it's pronounced like a French cow talking in mu. Bad joke, and I don't give a shit. Still like it. All right. Here's one that's even a little worse. I want you to realize something. What is 10 divided by 2? This is groundbreaking. What's 10 divided by 2? 5. What's 10 divided by 5? 2. See how those can just switch places and it's still true? Of course, because if I divide 10 by a piece of it, I get the other piece. So one thing I can do right at the top of the bat is just switch these. It's a really good thing to realize from algebra is when I have something equals a fraction, I can just switch that thing with the bottom and it's still true. I would multiply both sides by square root of n, divide both sides by e, so I would get here. And then what's the last thing I need to get n by itself? Square both sides. So we got n equals z become an s over e squared. And yes, I do write this bad, so sorry. Huh?
Should be a L.
Yeah. This is how you become a doctor, just so you feel better next time you go for a checkup. Handwriting's so bad, I'm like, senior doctor. This should be a simple question. How do I find the average of these? Add them all up. Divide by 5. Right? So what do you get? 17, 28, 39? And how many numbers? There's 5. The quick way to divide by 5 is to double, alright, let's see if you get this. Quick way to divide by 5 is to double the top and bottom and then move the decimal back once. If I double the top and bottom, I get divided by 10. So if I take 39, I double it, I get 78, move the decimal back, I'm done. Because if I make it divided by 10, it's easy as shit to divide by 10, right? Well, divided by 5 is almost divided by 10. And a lot of you guys are like, well, if you would have let me have this little thing, again, that does it. We made numbers. We need to know how to use them. We are in control of them. They don't control us. Okay. So number 6. What is it? 6. Number 6 is an interesting one. I'm curious how you guys did number 6. Two averages. How do you mean? No, you got to be careful. Okay, you can add these, sure. Nothing wrong with that as a first step. Tell me this. If I told you 3 numbers average to be 80, do you know what any of the numbers are necessarily? They could all be 80, right? Or one could be 78, one could be 80, one could be 82. I just did an interesting thing there. If I take 2 away from one and add 2 to the other one, they still average to be 80. Why? If 3 numbers average to be 80, they have to add to be what? 240. Because how do you get an average? You divide by how many there are. If it's got to be 80, multiply by 3, the sum's got to be 240. Think about it. All right. So one way to do this is algebraically. What's the grade on that third test? We don't know yet. Stop telling me the answer. I'm just starting this project. What's the grade on the third test? I don't know. So what do we call it? X. Why do we do that? So we got something to work with. That's why. If I knew what it was, what would I do? 81 plus 72 plus x divided by 3 is supposed to be 80. That's the power of algebra. I don't know this. All right, pretend like you do, and then do what you would do normally. Right? I'm going to pretend like it's x. I know what it is. It's x. So I would add them up. Now I can solve. Multiply by 3. Add these things up. Put the plus x there, Jeff. There you go, buddy. So you get x equals, what did you guys said it? 87. Now here's a really cool way to do this. 81, 72, and something, right? Watch this. It's kind of cool. How far away from 80 is 81? 1. How far away from 80 is 72?
8.
Down 8. So overall I'm down 7, right? So the last one better be up 7 so that altogether I get 80. Cool? You guys ever... That's kind of related to if they were all 80, 80, 80, 80, the average is 80. Well, if this was 78, this one has to be 82. So that's basically using that idea to an extreme amount, right? I love that. This is called making math your own. See, this is what you would do in algebra class. This is beautiful. This is what you do as another tool. Algebra is just one tool. Sometimes it's the best, and sometimes it's not the best. Okay, I like it. Okay, do me a favor. I forgot to do this. I do want to have you turn these in, so put your name up here. Somewhere up here. And then pass them to the middle here.
turn the lights on? Yes. Two rooms, joined in.
Late. All right, you're gonna freak out, aren't you? I need rooms like this, but I will. Okay. You need to turn around. All right. Let me see. Maybe it's better. Sorry, I gotta figure this room out real quick. I think that'll be good. Yeah, that's good. All right. Okay, so we're going to get a little bit into chapter 1. And just so you know, normally throughout the semester, I obviously will lecture a bit, but I also have like group worksheets and stuff like that, so I'm not going to just be spewing information at you the whole time. Today's going to be a lot of talking. It's already been a lot of talking. Chapter 1 is definitions, just definitions. So what I try to do is set up a scenario that would require a statistical analysis, and then bring up terminology as it would naturally come up. So stay with me now. There's just something about all Grossmont. Let's do this. I always talk about Grossmont students. There's just something about Grossmont faculty that you'd like to know, like the percentage of Grossmont faculty that drink Guinness, or the percentage of Grossmont faculty that something, or the average age of Grossmont faculty, or whatever. Anybody have something you want to know, or you guys are like, I don't want to know shit about these people, just tell me what I got to do. Any interest at all? Give a you do?
I do.
What?
I'm interested in the percentage of staff that's older than I am.
Oh, that's different. Okay, so you're going to have to tell us how old you are.
42.
42. So the percentage of faculty at Grossmont College that are older than you. Okay, I love it. This kicks ass. I was so happy when I was 42, because I don't know if any of you guys know what 42 is. There you go. It's the answer to life, the universe, and everything. So enjoy this time. There you go. So we want to know the percentage of all Grossmont faculty over 42 years of age. And it could have been anything, just she spoke up. You guys did. How would I go about doing this? The most obvious way would be to do what?
How many faculty?
Say again?
How many faculty members?
All right, I will eventually have to know how many. But obviously, as I do this first thing, I'm going to see how many there are. Collect data, sure. How would you do that? Just say it in English. How would you get started?
Find the age of all the professors.
Okay, where would you find that? Find the age of all the professors.
Survey.
Okay, survey. Okay, so we got a problem already, don't we? So one way is to talk to every faculty member and ask them what their age is. Maybe ask for an ID, in case any of them are like, right, and say, what is it? I'm a licensed statistician. Show me your freaking ID. But do we have like time or resources if it's just you doing this? Are you able to talk to every Grossmont faculty member? Is every Grossmont faculty member easy to get a hold of?
Yes.
Yes? Have you guys taken many courses? I'm sorry to say this, but some of us, some of my colleagues are not easy. And I don't blame some of them. Some of them are, of course, actually, a large percentage of them are part-timers. They are what's called adjunct professors. And I was one for several years, teaching at 3 different colleges. So you really couldn't be in any college for any length of time. I had my office hours were the 10 minutes before class. I mean, it's just the way it was. So some of you should know that some of your professors, you don't see them unless they're in class with you, right? And they might not want to just spew their age out at you in class. I don't know. So can we all agree it would be kind of at least difficult to talk to every Grossmont faculty member? Would we all agree?
Yeah.
Yes. So we're going to have to do, instead of talking to what's called the population, collection of all items or people we want to describe, what are we going to take instead? We can't talk to the entire population. We're going to talk to a
Just like a random sample.
sample. And we hope it's going to be random. Let's just put down sample first. Because their sample has the same definition if it's good or bad. So we can take a sample of, and so a sample is a subgroup of a population. For me, this is really good writing so far. All right, so we should already kind of know that coming in. You should know those two words. Right? So one way to do it, I ever heard somebody say a suggestion. One way to do it was a survey. And how would you accomplish that? What would you do? How would you survey Grossmont faculty? Anybody? You would. I would talk to them. Well, that would mean what? Yes.
I said send an email.
Send an email. Yeah, why not? You do have access to every Grossmont faculty email, right? That would take a while. So you could send an email out to every faculty member, but you're not going to hear back from everyone, are you? Okay. Or what could I do instead? If I'm like, I don't want to write that many, I don't want to copy and paste that many emails, you could actually select a sample, right? Now, what if I go to the faculty email page and I just take all the people whose last name starts with an A, because that's right there, you know? And I'm like, this is fine. There's a lot of people start with an A. What's wrong with that? Anything wrong with that?
It's not random.
It's not random. What the hell's random mean?
That each person, each sample of the population has an equal likelihood of being selected.
I like it. That would be simple random, but that's even better. Random is every person in the population, everything or person in the population has an equal chance to show up in the sample. Like, and now think about it. If I was trying to say something about Grossmont students, and I use you as my sample, is that random? If I use this class as my sample, is that random? No, it's not. Is it true that every Grossmont student would have been able to sign up for this course? No. Isn't there a prerequisite on this course?
Yes.
All right then. And not everybody can take it at this time, right? And not everybody needs to take statistics, right? So there's a lot, if I don't try to randomize, meaning give everything in the population a chance to show up, then I automatically have built-in biases, more than likely, right? There's a reason you're all here, and maybe that reason you're all here has something to do with what I'm studying, which means what I'm studying is not going to come out correct. It's going to be skewed one way or the other. You guys semi with me? So I love it when there's polls or they have people calling in. Who are the people calling in to talk about some issue?
People that care the most.
People that care the most. Very often there's people that want to yell and be heard, right? And they're often going to have an opinion that goes one way. Very often, right? Oh my God, especially nowadays. Holy shit. Okay. So random, little sub note here. Random sample, it seems very important, is one where let me try to write a little bit mathematical. Every element in the population has an equal chance to show up. Has an equal chance to be chosen for the sample. Right? And then I always have in my head that scene from Toy Story, the claw. Everybody had an equal chance. The claw.
Well, as a master, he decides who will go and who will stay.
You got to develop some kind of religion in that case. I sure would if there's a claw coming down from the sky. I think I'm going to subscribe to some religion. All right. So we got a population that we want to say something about. We have the reality that sets in that we can't talk to everybody, so we got to take a sample. And what is it we remind me? So we want to do the percentage of Grossmont faculty over 42 years old. So if I said, let's say this. there's something called the parameter, which you gotta love these next two words. And there is something called the statistic. All right. The parameter is a numerical description of the population. The statistic is a numerical description of the sample. You can't beat that shit, right? I mean, how can you forget that? I love people like, it's a sample, so this thing must be a parameter. Wait a minute, come on. Parameter goes with the population. Numerical description, most often an average or a percentage. Numerical description of a population. And a statistic is the same thing, but of a sample. So these are often sound exactly the same. If I said 38% of all Grossmont faculty are over 42, which is probably backwards. Let's say 62% of all Grossmont faculty are over 42 years old. That is a parameter because of one word especially, the word all, right? It's not always the word all, but if there's a word all, it's a giveaway. That's everybody. That's a parameter. If I say 62% of the faculty that I talk to are over 42 years old, that would be a statistic. Is that difficult? No. Right? But some of you guys will find a way. Okay. Notice the parameter is almost always an average or a percentage. So if they ask you, write the parameter for the situation, and you don't include the word average or the word percentage or proportion, you are probably wrong. Okay. Now, so we have the groups that we're going to talk about. These are the people you want to say something about. These are the people that we'll actually be able to analyze. This is what we wish we could get, and this is the best we can get. You with me? And very often you'll see anybody into politics at all, or, not even voluntarily, just anybody voted that is able to vote? You guys are like, I'm not going to tell you. Shit. That's my right. Not voting is not. That's true. That's true. But I'm going to try not to rant too much. But so if let me see. What do I want to say? Oh, so you'll see very often when they're talking about an upcoming election, they'll say 42% want to vote for this proposition, 38% would vote against it. So then, would that mean that all right, it's going to win? Sure. What shows up at the bottom of the screen or the bottom of the article?
Undecided.
Plus or minus, undecided, but plus or minus 4% or something at the very bottom. Because they based it on a sample. So they got a statistic, and then they tried to describe what the parameter looks like it's going to be. So they took a sample, and they get 38% of the people. And then at the bottom they'll say plus or minus 4%. So they're like, I think that the real thing is somewhere between 34 and 42, plus or minus 4%. Are you guys semi with me? Later this semester, we'll actually see the math behind that plus or minus 4% number. We'll calculate it ourselves. So you probably aren't as excited about that as I am, but oh well. So, once I got my sample, I know what the shit I'm trying to talk about. What am I going to do with my sample? What exactly going to do? You got your sample, you got all the faculty you chose, you had them all show up or something. You email and said, come in, I want to look at your face, and if you say you're 30 and you look 70, I'm not going to believe. Say, have them all come. What are you going to do? Or you email them. What are you going to say in the email? What are you going to say? What are you going to say? What is it we want to get? Yes, you're going to say, how the freaking old are you, right? Maybe not like that. 2 reasons, because there's one, you don't say freaking, and 2 is weird grammar, but how the freaking old are you? So the question you ask is related to what's called a variable, and we all know that word all too well. Why is it called a variable? What's a variable in algebra? Could be x, right? And why is it called a variable? Because its values varies. All right, I love it. Because what could x represent? It could represent all real numbers or whatever, right? X could be whatever. And you solve for it, you see, oh, it's 7. So X could have been anything, right? So in statistics, same idea. Why is the question that I'm going to ask related to what we call the variable? Because how many answers can a question have? A lot, right? Probably in this case, it can't be 11. That'd be some major Doogie Howser shit, right? How old are you? 11. Any teacher? Yep. Okay. All right. But it still has many possible values. That's why we call it a variable. So what question would you ask here? How old are you? So what would the variable be? The age of a faculty member. See how it's related? The variable is related to the question you would ask. So the variable in general is, how do I want to say this? Related to the question you ask. That's all I'm going to say. So in this case, it would be age of faculty member. Another way to look at it is, well, let me say it like this. What's the data then? Values, exactly. The answers. Variable is the question you ask. Data is the answers you get. It's what you would write down as you're talking to people. So if there's a problem in the book that says, what's the data? Think to yourself, what the shit are they writing down? That's the data. If it says, what's the variable? Think to yourself, what are they going to ask? That's related to the variable. See how the words do flow right along with the thing we'd have to do to get at the answer to this? Yes, there is. So data is all the answers to question. See. Okay. I like it. So if I talk to 47 faculty members and I find, like I said, 60% of them are over 42, what would that be?
Like half a person's over 42 or something?
Say again?
Like half a person over 42 or something?
Yeah, the half of them feels good and the other half feels, like it's ready to retire. I love my smart asses. What would that be? Statistic. Why? Because they just described the sample. Don't make more out of this shit than it is. That's it. Is it describing a sample? Oh, it's a statistic. Is it describing everybody, the whole population? Oh, it's a parameter. Parameter. All right. So what we're going to do now, I'm going to do just a little bit more. We'll let us out a little bit early. Let's get into deep stuff with variable and data. Let's get a little more specific there. Because it's kind of loaded. I think I got all that in there. Here, for those at home, there's that stuff. Is it still going? I love you guys. Yeah, okay. You in the front row, you just got to help me, okay? A little bit. Or don't. It's up to you. You're here, so hey, you're like, screw those people, they're not here. So let's do this. Let's talk about what kind of data we can have. There's two main types of data we can have. And they relate to the two main types of things I'm looking for. So it could either be qualitative data, also known as categorical data. And then there's quantitative. Now one of these is very in your face. Actually, they both should be. What's the root word of quantitative? Quantity, I like it. And qualitative? Quality. So quantitative is the truly numerical data. Right? Truly. Numerical. What do I mean by truly numerical? They're numbers that when you add and subtract them and all that kind of stuff still make sense. Qualitative is categorical. Names of stuff. So an example of something that looks like it might be one or the other is like a zip code. 91941, zip code, right? Is it a number? You would say yes, but is it truly numerical? If I add or subtract two zip codes, does it mean anything? If I divide your zip code by my zip code, I'm like, 1.7 times better than you. What the shit? No.
So it would be qualitative, just the name of a region, right? So security number, all that kind of stuff. What about, temperature? If yesterday was 76 and today is 74, if I subtract them, does that mean anything?
Yeah.
Of course it does. It was 2 degrees warmer yesterday, right? Wouldn't that sentence make sense? But if you say, I went, my zip code was 7 better than it was. What? What the hell are you talking about? You guys coming up with a little bit. Okay. All right. So some things that are numbers aren't quantitative because they're not truly numbers. Like your social security number is not a number. It's a name for you. Right? Thankfully, the predictors that would be really our name never came true. But some things we are. All right. Now, this isn't that hard to keep down between these two. So let's get a little bit deeper. There's something called, so here's another level, discrete versus continuous. So some data that's continuous would be data that could be any number. So if I said how many doors are on your vehicle, and you say to me 3.5629744 doors, aren't you a little concerned about? I want to see this shit. There's like a door that's phasing in and out. 70% of the time, that's a door. What? Or how many TVs are in your house, and you say 3.874. Depends on the day. Sometimes that's a TV, and sometimes it's a microwave. It's weird. Like, what? So things that you can count that have only certain options for an output are discrete. What about price of gas as listed at a gas station? How do they list the price of gas at a gas station? Give me a price of gas. What is it right now? It's like 3. Yeah. Well, what do they? Some of you guys know how they do this, right? Don't you? Do you? 309. So it's really freaking 310. Jesus, right? Look at that. Ever notice? So is this continuous or discrete data? It would be discrete, because can you ever see, would you ever see this? No. So it can't take on every value in an interval. That would be continuous. Continuous is something that you would draw a line and it goes through every possible place. Discrete jumps over possibilities, right? So what about the weight of your backpack? Is that discrete or continuous? Continuous. It has nothing to do with the way you would say it. If I ask you, how much does your backpack weigh? And you go, about 10 pounds. The fact that you made it a whole number, does that make it? No. What could it be? 9.8746392222247 forever pounds, right? So that is an example of continuous data, because it could take on any value in a continuum. Now, if I ask you how many books you got in your backpack, that's freaking discrete because you can count it, right? You don't say, well, I'm 40% okay with this one, so I got 3.4. It's a freaking book, or it ain't, right? Okay, maybe. So, countable, uncountable, right? We can talk about that a little bit, but anyway. Continuous, it takes on any value. It could take on any value. So if I said the average number of kids in a family is 2.7, what kind of data was that? If you say continuous, what was the data in this case? Again, what's data mean? What's data? What's the word data mean? All the answers to the question. What would I have been asking to be able to get to the point where I can say the average number of kids in a household is 2.7? What would I ask people? Now, if you say the data is continuous, I should be able to write down any value. Like, how many kids you have? 3.7444296, because this one, What about that one? I don't want to see your 0.7 kid. Don't bring him down the stairs. I won't know what that is. Well, you know, we do some Dr. Moreau kind of shit here. You know? Did we get that? Father. If you have no idea what Dr. Moreau is, I'm sorry. Anyway, so the average is something I do with data. The number I say after the average doesn't mean shit about like what can happen individually. Sure, the average could be 2.7 because maybe I talked to 10 people and they have 27 kids. So isn't the average 2.7? Did any of them have 2.7 kids? Of course not, right? So don't look at the number and say, oh, it's this. If I said the guy was 6 feet tall, is that continuous or discrete?
Discrete.
No, you don't look at the number. It's continuous. Why? They could measure their height more and more and more precisely, and it would make sense, right? Maybe they're 5.9234773 feet, right? And they could just be more and more precise if they want to, and it would make sense. Can you measure the number of doors in your car more and more precisely? No, right? You can't say, well, it's 3, but if I really think about it, it's 3.06. No, what are you talking about? Now, I understand some cars have half a door, right? Some trucks. But that's still only certain values. You can't have a quarter of a door. Well, I don't know anymore. Right? You're not going to have a tenth of a door and a hundredth of a door. What the hell's that mean? How tiny are you? What is the 100th of a door? Maybe. So do not look at the number I give you. And I'm not trying to be tricky. I want to make sure you focus on what you need to. What would the answers be to get here? The average temperature was 30 degrees Celsius. Discrete or continuous? Continuous, because how could I measure temperature more and more and more precisely? It would make sense. Yes. Okay, maybe. Okay. Let me see.
Is it discrete maybe a qualitative?
Oh, okay, so no, discrete and continuous reference truly numerical.
Okay.
Yeah. So I should have made that, this is blowing that up. So to stick with my promise of letting us out early, we're going to let us out. We got pretty deep into chapter 1. We still have a bit to cover on Wednesday. I'm pretty sure we go through 850, right? Yes. Okay. So this is a little bit early. Oh well. So on Wednesday we'll take a little tour of the campus, and we'll finish out 1 and get a little bit into 2. Chapter 2. You need an ad code or something coming up? Oh yeah, I have no idea. Let me see. We definitely finished 1-1.
What a pause.
Then we did a little bit of 1-2. So we finished 1-1 today.
Just echo.
Oh, echo.